Tutor, where school is made simple. Let's go. In this video, we're going to look at the slopes of parallel lines. We're going to start, however, with a basic rectangle. And here we see the rectangle ABCD. We know that a rectangle has two pairs of parallel sides and two pairs of equal sides, and that they have four 90-degree angles. So I can say that AB is equal to DC, as we see here. Similarly, that AD is equal to BC, just as we have here. So now let's pick a point alongside BC, and we're going to call this point G. And then we're going to connect point G to point D, creating our line. And then I want to create a line parallel to that through point B. And then finally show where this new line intersects side AD, which is at point F over here. Then I'm going to label each of these segments so that I have segment T, U, V, and W. And then I'm going to focus not on the rectangle, but on the quadrilateral that we've just formed, this parallelogram. And parallelograms are similar to rectangles. They have two sets of parallel sides and two sets of congruent sides. They do not, however, have the 90-degree angles. And let's take a look at how we can move point G and change this middle quadrilateral, this middle parallelogram. And then let's start to look at some other things that can happen. If I look simply at the left side with A and D, I know that A and D is comprised of these two segments. More to the point, I can say that T plus U is equal to AD. We're going to come back to this in a moment. Similarly, we can look at the other side of the rectangle and see that BC is really just V plus W. And since I know that AD is the same as BC, then I can say that T plus U equals V plus W. I also know, going back to the quadrilateral, the parallelogram, that U is equal to V, because the two opposite sides are congruent. Once I know that, I can substitute U for V in the first part of the previous equation to get T plus V equals V plus W. And because I have V on both sides, I'm going to subtract V and finally see that T equals W. And then I'm going to use this again very shortly. Now, I want to move away from this parallelogram and focus instead on the two triangles that were formed. When I do that, I can start to analyze the slope of the line because I know that point C is a 90-degree angle. So I can say that the slope of line FB is going to be equal to rise, which is T, over the base, which is AB. But since I know that T and W are the same thing, I can say that that's the same thing as W over AB. Looking at the slope of line DG, I can again come back to my triangle and look at rise over run. Well, my rise component is W, my run component is DC, W over DC. Now, the same way that I did before, substituting, I know that DC is the same thing as AB. So let's substitute those two. And we get that slope of DG equals W over AB. Since both of our slopes are equal to W over AB, then I can clearly see that the slope of FB is equal to the slope of DG. This confirms that the slope of parallel lines are equal. Now let's look at the measurements, just as a further confirmation. I can see that the slopes are both equal, and I can even animate my point to see further that no matter where I move this, my two slopes are going to be equal. And this is further proof that the slope of parallel lines are equal.